Welcome to the first session following lunch. This session is presented by Adrian. It should have been presented by Adrian and Federica. Adrian will introduce himself and explain what happened to Federica. Excuse me. You're on mute at the moment. You can put any questions in the chat. I will interrupt Adrian if it's a question that really needs to come out at that particular time. Otherwise, we can check all the questions at the end. Thank you, Adrian, and over to you.
Okay, thank you, Anna. Thank you, everyone, for joining today's session. My name is Adrian, and me and my colleague Federica are part of the IBM Software Migration Project Offices team, where we do migration services from competitive scheduler tools to IBM Z Workload Scheduler. We have prepared that presentation together with Federica, but unfortunately she won't be able to join me today due to personal reasons, and I'll be leading you through the whole session. In this presentation, I will show you how WAPL, the Workload Automation Programming language, enables the advanced calculations and logic capabilities that go beyond the limitations of the standard JCL directives. Whether you're dealing with the complex date calculations, dynamic variable handling, or let's say conditional execution logic, WAPL gives you that flexibility to control and enhance your workload environment. So let's dive and uncover what makes WAPL a powerful tool in the IBM Z workload scheduler environment. In today's agenda, we will cover the JCL directives, overview and common limitations they have, solutions that WAPL can provide for to overcome those limitations, practical integration strategies for combining JCL directives with WAPL, and also real demo examples. So let's start. What are the JCL directives? The JCL directives, excuse me, the JCL directives in IZWS are special commands and instructions inside the JCL that tells IZWS how to handle the job, which variables to substitute, and how to manage the inclusion and exclusion of JCL lines. Let's take a look at here a few common examples. In example 1, we can see the set form directive. That directive is used to define the format of the dynamic supplied variables. The set var is used to create a temporary variable that can be used within the JCL for calculations further down. In this example, we can see that on the T var 1, we will assign the occurrence input arrival date, and then we'll add 1 month to it. So we'll have the result on the T var to set to 1st of June, and the T var 1 will be the current date, 1st of May. In the second example, we have the begin and end directives used in pairs to control the inclusion and exclusion of JCL lines. And this is based on the evaluation of the OPC statement. In this case, if the application ADID name is equal to the APPL ASAP 2025, we will have all the JCL lines between the begin action include and OPC end action included or executed in the JCL. In the third example, we can see the fetch directive. That directive is used to dynamically include lines in your job either fetched by the PDS member or supplied by an exit. And in this example, we'll fetch the ASAP25 member if the evaluation statement again is equal to the application name is equal to the ASAP 2025. These JCL directives makes JCL more flexible, especially when creating a dynamic and reusable jobs. But they comes with some limitations. Even though they're too useful, I'll go and through some of those common limitations that they have. The first common limitation of those JCL directive is the complex data calculations where they are limited. Let's say, for example, we want to calculate the first Tuesday of the month, or if we want to calculate the, let's say, the first working day after 30 days from now. This will be difficult to be done with the standard JCL directives. Another limitation that JCL directives have is the begin and end statements, which cannot be nested. And also, you cannot perform a fetch within another fetch directive. This is another big constraint. The calendar definitions are not allowed on a job level. This is another limitation they have. And you must rely on the application calendars or either the default calendar to do some calculations. The last limitation listed here is the temporary variables. Temporary variables created within the job's JCL cannot be reused by another job later running in the plan. So what we can do in this situation? Here WAPL comes to help. What is a WAPL? Many of you may be already aware with the WAPL language, but let's say for those who are not, I'll do a brief explanation. WAPL stands for Workload Automation Programming Language, and basically it is a scripting and control language used in IBM Z Workload Scheduler to automate the job scheduling activities. The main purpose of WAPL is to dynamically create, update, let's say, delete objects in the database like jobs, applications, and workstation, and etc. Now, let's see the var_date command. The var_date command in WAPL allows users to perform complex date calculations. This command is particularly useful for dynamically setting and updating dates variables. It is used to identify a single date within a specified year. With the command, you can, let's say, define a specific fixed date. And once you define that specific fixed date, you can then add, subtract days, months, and even years from that date. And then you can calculate dates based on that variable. And I would say that this is a very powerful command in WAPL. Now, let's have a look at a few simple examples of WAPL statements. The var_date statement. In this example, we have the myvar variable, and we'll use the current date as a base, and we'll apply an offset of 2 days to that current base, and the result will be stored in the myvar variable, which will represent 2 days from today's day, and this will be 3rd of May, sorry. The var set statement is used to assign a value to the myvar variable. In this 10, it will assign the value 10 of myvar variable, and we will save it for a further subsequent logic use. The var save command is used to store a previously defined variables in a table, enabling their use by another jobs later in the scheduling process. Next slide. On this slide, we'll see two simple examples of the var date statement to identify dates. In the first example, we will calculate the first day of the GSE UK conference. The variable GSE first day will get the value of the last day of month April, and this will be third uh, third yeah third 30th of April, and we'll do an offset of -1 day of that date, and will fall on 29th of April, which is the first day of the GS UK conference day. In the next example, we will use the previously calculated variable GSC1 day as a base, and we'll do an offset of +2 days to find the last day of the GS UK conference, which will be 1st of May. Now I will run a live demo on our system to illustrate to you how this example is implemented on the system. Oops, my session is frozen. Let me reconnect. So here are my examples. I'll take the WAPL GC1. This is a simple JCL job where I have the WAPL statements inside the CSIN of the job. And I would expect to see the output of the WAPL statements inside the WAPL out dataset once the job finished. Also, I will display those two variables in that output dataset so we can see the result of the execution of the WAPL statement. So let's run the job. Okay, the job has ended. So now let's go and check the output. And here it is. We can see now that variables has been resolved and they're pointing to 29th of April, the first day of the GS UK conference date, and 1st of May, which is today, the last date. Now let's go back to the presentation. Let's have a look at a scenario 1 where we are using the var date command. Let's say that we have an application which is scheduled to run 2 days in a week, on a Monday and on a Thursday, but only on the first Thursday of each month. One of the jobs should include invite job statements and send a promotional email to the customers about the weekend promotions. Let's dive and see how we can implement this with WAPL. To identify the first Tuesday of the month, we will use those two simple examples. In the first example, with the var date statement, we can simply calculate the first Thursday of the month May, where we have the month May hardly coded. In the second example, we will calculate the first Tuesday of each month, and for that purpose, we'll use and pass the month as a three-letter variable to the statement month. The today variable will get the value of today's date, and by default, the var date statement returns a format of YYMDD. So we use the format keyword here to change the format to triple M. And once we have that format, we can pass that acceptable format to the month statement dynamically. So we'll have now the month calculated using the dynamic support variable. And this is very useful and practical when you have a job schedule to run on a monthly basis and the month should be substituted each time. So now I'll proceed and run another demo on my system to display the result of those two calculations. Here is my second example. And again, I have the WAPL statements inside the scene of the JCL. And as you can see here, I will display the first variable and the second variable in the output data set. I would expect to see the same months. Yeah, first Thursday of May is the today's date, 1st of May. And again, I'm having the same statement. First Thursday in month May is again the same date. But if I run the job next month, here I would expect to see June and then another date. In the scenario 2, we are looking at the monthly audit application. There we don't want the validation to start immediately once let's say, the audit job completes. But instead, there should be a mandatory 30-day buffer period to allow the teams enough time to review and resolve some potential issues. And only on the first working day after a 30 days period, we want the validation to be triggered. Let's see how we can accomplish this with WAPL. To achieve this calculation, we will use the calendar keyword with the WAPL. Unlike the JCL directives, which don't support the calendar definitions at the job level, WAPL allows us to directly assign a custom calendar to an individual job. And this flexibility is one of the WAPL key advantages, allowing sophisticated date-based calculations. Here, the demo calendar is having the Saturday and Sunday as a free days, but also it has another days defined as a free days. You can see that 31st of May, 2nd of June, which is Monday, is also a free day. And this is how the calculation of the next workday after at least 30 days from now is done. For the base date, we use the current date, which is 1st of May, and will be assigned to the today variable. And then we will use that result as a base to the next variable, today plus 30 days. And we'll do an offset of 30 days. and will fall will fall on the 31st of May. Excuse me. Once we have that calculated, we will use again an offset plus 1 day, but this time we will use the unit workday based on a demo calendar. And since we have Sunday and Monday 2nd as a free days, will fall on the 3rd of June as the as the first working day from now. So let's proceed and see how we can do this in on the system and check the results there. Here is my next example, and here it's again the WAPL code that we saw previously on the presentation slide, and I'll again display that calculation of that variable. So let's run it and check the result in the output dataset. We can see the next working day after 30 days from now based on that calendar will be 3rd of June. And again, I would say this is very helpful because in that case, we have used a custom demo calendar, which is different than the default one. If we had used the default calendar, which has only Saturday and Sunday as a free days, we would fall on the 2nd of June, which is a Monday, as the first working day instead of a 3rd, as it is now. In the next slide, we will see a slightly different scenario where we have to calculate the first Monday at least 30 days from now. And this is achieved by specifying a day of the week in the unit statement. In the unit statements, you can specify days of the week, like Monday, Tuesday, and etc. And combined with the offset keyword, you can calculate the preceding or the following days of the week from the original date. Now let's run another demo on the system to display the result of that. Again, the same similar code as the previous one, but now I'll have the Monday as a statement in the unit defined. And I'll display the next Monday variable. So the next Monday after 30 days from now will be a 2nd of June. Okay, well done so far creating those variables. Now we have a different scenario 3, where I'll demonstrate you how to combine the strength of the JCL directives and WAPL to enhance the scheduling logic. After successfully creating those variables with WAPL, the next step is to reference them and use them across other jobs in the application plan. So let's take a look at how we can combine them. Again, let's return to the example where we have an application which is scheduled to run twice in a week, on a Monday and on Thursday. Only on the first Thursday of each month, the job should include a member to send a promotional email to the customer about the weekend promotions. The first Tuesday of the month is the today date, 1st of May. Now, let's review how this application looks like in IZWS. Here is my application in the current one, and it has an input arrival date of 1st of May. And you can notice here that it starts with the W key characters and is a weekly one. So when I browse my application, we can see that we have 4 operations. The start and the end operations are the non-reporting dummy one. And I have 2 other jobs. The second job is my WAPL job, which will be used to do the WAPL calculations of the variables, and it will save them in a JCL table, which table will be used once this job is done by the next CPU job. And this CPU job will read those variables from that variable table and will substitute them in its JCL. So if I go and browse the JCL of my WAPL job, you can see it's a simple job, but this time I'm having my WAPL statements inside a PDS member, and they'll be fetched from there. Now I'll return back to my presentation so we can see how the WAPL code looks like and what this code will do. This example show us the next big advantage of the WAPL, and this is the using of the begin and this is the use of the if else if then else statements. Those statements are used to overcome another limitation of the JCL directives, and this is the nesting of the begin and statements. The WAPL if then else logic can be used to do a nesting on a multiple levels compared to the limitations of the begin and directives. As you can see here, we have a nesting on 2 levels, the first level and the second level, which cannot be performed with the JCL directives begin and end. The keyword table here is used to assign a JCL table where the variable can be saved. If the variable table does not exist, it will be created automatically during the first time when you run the code, the job. The var save command is used to save all previously defined variables to a specific variable table. In that case, it will be the GAC vars table. So let's take a look at the code. The OC date here will use the occurrence input arrival date as a base, and then it will format that base in the 3 letters character of the month, and it will be assigned to the month variable. The when run var value is set up to the first 2 characters of the application name, and then we'll have an evaluation if that variable is equal to the string of W key. And in that case, this is true because our application starts with the WK. And when that's true, we'll calculate only the first Thursday of the month as we did before, and we will assign that value to the first THU1 variable. Then we have a second evaluation where we check if the application input arrival date is equal to the first Thursday of the month. And if that's true, we'll set up a value of plus 2 days of that first Tuesday of the month to the variable weekend and save it in that table. And also here we'll set up the value of 1 on the run job variable. And again, we'll save that variable in the GAC vars table. If the above evaluation is not true, we'll set up the run job variable to value 0. This is important to be noted because we'll see how this is used in the next CPU job, that run job variable. And finally, we'll save all those previously defined variable in that JC vars table. This is how the JCL variable will look like after the WAPL job runs. Here you can see when the WAPL job completes, it will write in that table the value of those three variables, the name, the value, and also it will display detailed information about the name of the job that updated those variables, the JES ID, and also the date when this was performed. This is how the CPU job looks like. So once we have those variables written in the GAC vars table, the CPU job can use them. Here we have the OPC statement table, which points to the table where the variables should be searched in first. Then we have the the OPC comparison statement, which will evaluate if the run job value is equal to 1. And if that's true, all the statements between the begin action include and begin and end action include will be executed. So let's run the demo on our system and on that application and see how it will behave. So this is my WAPL job and I'll execute it now. Okay, the job completed. Now let's go and check how the table looks like. So here is my table. And we can see that the job, and here we can see those three variables written in that table. We can see the value, the default value of those variables. We can also see the job ID, the date, and we can also see even a timestamp when this was updated by the job. Now let's return back to the application again. And now I will run my CPU job, which will use those variables previously defined by the WAPL job. But before doing that, let's check how the JCL looks like. Here we can see the JCL before it's been resolved, and we can see also the OPC statements. We have the OPC table statement, which will point to the table which has previously been defined, and the variables will be substituted from that table. As I said before, here we have that comparison statement, and if that's true, everything between the begin action and end action will be executed. In this case, we have in the CCIN a text which will be the email which will be sent to the customers about the weekend promotions. You can also note here that we have another variable which will be substituted once I run the job. Here we have a two comparison statement. This is the first one, and this is the case when we run the job only on the first Thursday of the month. But when we run the job on a date different than the first Thursday of the month, the run job variable will get a value of 0, and we will just only run that part of the JCL, and the job won't do anything. It will just simply execute the IFBA 14 program. So now let's run the execute that CPU job. And let's take a look at again the JCL, the resolved one. You can see here that the variables has been resolved, and now we have 1 equal to 1. So everything here will be honored and executed. And you can see also that this variable, the weekend variable, has been substituted here, and it is pointing to 3rd of May. So let's go back to the presentation. And here is how the email would looks like. The users should receive the email that the new promotions will be available starting from the next weekend. And here we have the date that has been calculated previously. So let's summarize the solutions that has been provided by WAPL to overcome the JCL directive constraints. The first constraint is the complex logic date calculations. The solution that WAPL provides us is the powerful var date statement, which can be combined with another WAPL statements to provide us more flexibility. The next limitation, the begin-end statements, which cannot be nested. Again, WAPL provides us the if-then-else statements, which can do a multiple level nesting. The third limitation regarding the calendars, which cannot be specified on the job level. Again, WAPL provides us the calendar keyword, which points to a specific calendar, and that resolves this limitation. And the last limitation in that list is the temporary variable created in the JCL, which cannot be used by another jobs running later in the PON. And the solution provided by WAPL is to create and save a variable in a JCL variable table that can be referenced later in another job. And that has been all for that session. Thank you very much for your attention during today's session. I hope you found it interesting and that the solutions presented will be helpful in your scheduling work, especially when you're addressing some challenges during your daily work. If you would like to share your thoughts or feedback on the session, please do so using the following link. You also have the session code, which is 6Q, and you can use the QR code below. If you have any questions, you can raise them in the chat or unmute yourself and talk. Now I'll hand over to Anna.
Yep, so you can now unmute yourself if you have any questions about this. This was a solution that we certainly needed to exploit ourselves based on products that could do more than our JCL variables, normal JCL variables could do. So it was very useful to us. Okay, so if no one has got any questions, then it just remains for me to thank Adrian for having to do this all by himself, and to thank Federica in absentia because she helped him put it together. And yeah, Neil, you've unmuted yourself.
Yeah, just to say thanks as well. It's always useful to have a look at other ways of doing things.
Yeah, thanks, Neil.
And the presentation will, of course, in the usual fashion, be uploaded onto the GS UK website so that you can download it, the slides, and obviously the video as well later.
Thank you very much.
Thank you.
Okay. Thank you, everyone.
Cheers. Bye.
Thank you.